Hey, we've got here another integral. This one's from UNSW Integration Bee 2019, problem 15. We have the integral from 0 to 1, x cubed, 1 minus x to the 7th dx. Okay, so I've done problems really similar to this in the past, and basically two different ways. We've done it with just a regular u substitution, and we've done it with beta function. And so for this problem, I think what I want to do is I want to do it again with the beta function. I noticed I did a problem on the beta function a little while back and I made a mistake in the formula, so this will give me a chance to hopefully redeem myself and do it right. So let's look at our formula for the beta function. Okay, so we have here our formula for the beta function. Okay, and notice the similarity to our integral. We've got the same bounds, we're going 0 to 1, and we have this pattern of x to an exponent, 1 minus x to an exponent. And what this allows us to do is we can integrate with basically no steps, and we can just use this formula and get it in terms of the gamma function. And then hopefully this thing over here on the right is easy to calculate. It actually is for positive integers. There's quite a few values where this is easy to calculate. And so as long as we can calculate this, we're in good shape. So let's see how this is gonna work. So for my first step, I just need to figure out what is my z1 and z2 gonna be. Okay, but that's everything we need over here on the right. And so we'll just notice on these exponents, 3 we could write as 4 minus 1. So our z1 value is just going to be 4. And then doing the same thing for our z2 value, we could look at this as 8 or 7 as 8 minus 1. So that z2 is going to be just 8. And then next what we're going to do is we're going to go right to this formula, just populating with these values. So we're going to have gamma of 4, gamma of 8. Okay, and then the denominator is just the sum of the two, so it's just going to be gamma of 4 plus 8 is 12. And from here, you might be wondering, okay, how do we calculate this thing over here? How do we calculate the gamma function? Well, for integers, it's pretty easy. So we can use a formula, something like this. Say the gamma of n is the same as n minus 1 factorial. Okay, this isn't defined for all values, but it is for positive integers anyway. Okay, so now we'll just use this to rewrite this in terms of factorials. So gamma of 4, using this formula over here, gamma of 4 is going to be 4 minus 1, or 3 factorial. Gamma of 8 will be 7 factorial, and gamma of 12 will be 11 factorial. But what I'm going to do is I'm going to kind of try to write that out. So 11 factorial I'll write as 11 times 10 times 9, 8 times 7 factorial. That's just going to give us this nice cancellation right here. We could do more canceling. I mean, basically what's going to happen, let's take this 3 factorial and we can cancel a 3 with a 9. 10 we can reduce to a 5. And when you multiply all this stuff out, we're going to get for our final solution 1 over 1320. So that's it. I think when I looked on the answer key, I think UNSW did it the other way. I think they did it by substitution. But I think this is pretty nice doing it with beta function. So we'll stop it there. Thanks. Have a great day, everyone. Take care.